Hi, this is Richard Grills. I'm the product manager for lens technology at Optomec, and today I'm going to be showing you how to use PartPrep. We'll start by opening a file, and I'm going to choose this one, which is a model of a tooth. The first thing you can do is to move the part around using the left mouse button. You can move it on the screen left and right, up and down. Using the right mouse button, holding down the button, you can rotate it around. And if you hold the shift key and press the left mouse button, it moves it towards you and away from you, so you can zoom in and zoom out on the part. You can also adjust the view by coming over here and clicking on the different buttons to see how it looks: top, bottom, left, right, front, back, and the standard isometric view. Before moving on to slice the part, we need to check that the part is oriented correctly and the right size. We can adjust both of those using the Modify tab. First of all, to check the size, we look over here and we see that this part is actually way too big. It's a tooth, so it should be about 9 millimeters. Instead it reads 9 inches, and so that we know that the units have not been brought in properly. To scale the part, we need to scale by a factor of 0.0393, and then we press the OK button, and there we are. The part is now the correct size. Using that same menu, you can also factor by any scale that you wish to. If you wish to make a half scale part, you would factor by 0.5, and there the part is now half scale in all three axes. To get it back to the right size, factor by 2. In this case, this part is oriented correctly with the build axis straight up, but if for any reason it's on its side or you wish to turn it around in the machine, we use the rotate part dialog box. About X, Y, or Z axis, we can rotate by any number of degrees. The common thing to do would be to rotate by 90 degrees, either plus or minus, in one of these three axes, and in doing so the part gets flipped onto its side. In this case the part is already the correct orientation, so we can just put that back and we're ready to slice the part. In order to slice the part, we come into the Build Prep menu and hit Slice Part. The parameters that you see on the screen here are very standard parameters which are widely used and successful for a wide variety of materials. The layer thickness here of 12 thousandths of an inch and the hatch spacing of 18 thousandths of an inch have been used for many years successfully. In general, if you change either of these, change the other one such that the hatch spacing is 50% bigger than the layer thickness. So in this case, 18 thousandths is 50% bigger than 12 thousandths. These correspond to 0.3 millimeters and 0.45 millimeters. The hatch angles of 0, 90, 180 and 270 work very well for any part with corners. If you're building a largely cylindrical part with entirely smooth contours, what some people do is they go 0, 60, 120, 180, 240 and 300 on the angles. And if you do that, of course, don't forget to put 0.018 here and 0.018 here. For a square part, 0, 90, 180 and 270 works very well. The other parameters here should generally be set as they're shown. The resolution of 5000 is how often PartPrep assesses the side of the component to work out where it is. The higher that resolution, the better. PartPrep will match the shape of the part, but if there are any problems with the STL file, it's also more likely to find them and give back an error message. Sometimes it's necessary to turn the resolution down to 1000 or even 500, but in general leaving it at 5000 is fine. Hatch shrink, line width, number of contours, contour offset should be left as they're shown here. Sequential and marching should be left as they're shown also. If the part has sealed cavities, if it has a hole in the middle of it which is completely enclosed, check this checkbox, otherwise leave it open. All these parameters are excellent parameters to use to slice a part, and once you've got them as you need them, hit OK and the part is sliced. We now have the sliced part view where we can see how each of the slice layers look. The layer number is shown here, and there are 29 layers in this case. We can go up layer by pressing this arrow here, and we can look at layer 8 of 29, We can skip to a particular layer. If we want to look at layer 15, type in 15, press enter. We jump to layer 15 of 29. We can see how each of the layers looks. The red color indicates the contour. The yellow color indicates the hatch. We can also run through all the layers by pressing the run button, and we can go up. If you ever press the run button, it's good to press the stop button afterwards, otherwise it will keep trying to run it. The other feature which is useful here is the delay buttons. If we press the turn the delay up here and press run, then it takes it through more slowly, so it's easier to see how each layer changes. If we turn up the edge slightly and press run, it will run through each layer and actually draw out how each of the contours and hatch lines look. So you can verify how it's going to move on each layer and how the contours and hatches will progress. This can be useful on very complicated parts if you need to understand how the machine is going to move. In general, it's a really good idea to always run through the component, even if it's only quickly, just to check that all the layers are as you expect them to be, the hatches look okay, and there wasn't anything that went wrong during the slicing. Once you've done that, the final step is to come into the File menu, Save As, and save it how you wish to as a slice file, or if you're using the 850R, you can also choose it to save it as a G-code file. Hit Save, and the part is done. Thank you very much for listening. If you have any further questions, please consult your user manual or contact Optimet customer service.